All right, Jennifer, on to you.
All right, well, thank you. Claire, I wish I would have had your slideshow and your tutorial before I did what I did kind of as a backward design as an educator, so I learned a ton, so thank you, thank you. I'm sure a few of you had seen just—
You're welcome, and I'm happy for you to use these if that's helpful.
They will be, so I will credit you. So let me just get this going here and I'll share my screen. Okay, so I should probably share first, correct? And then go back to here.
It works best if you open your thing first so that you can choose it. Otherwise, we can see your desktop. And I'm comfortable with that. But yeah, just click share screen and then the window you want us to see, and click that, and off we go.
Okay, and then here. Okay, I don't know why I'm having a password audio device. I'm new to this too, Tasha, so.
No, I don't know why you have a password either, but interesting.
Oh my gosh, okay, I never saw that before, so this is my third Zoom experience, so I'm learning a lot. So do you see my screen?
We see your screen. If you want to go to presenter view, we'll be able to see, or yeah, however you want to do it, it'll be great. Or I'll just embiggen the slide. If you have if anybody watching has a hard time seeing the whole screen, like I'm okay right now, but if it doesn't, looks like the slide doesn't fit, you can go up to the top of your screen where your button says you're viewing Jennifer Taylor's screen, and there's a word that says more. Click on more, a drop down comes in, and you can pick either original size or fit to window. So whatever I pick, fit to window, and then it looks like it works out well for me.
All right. So is this looking good? Yes? Okay.
Yeah, it looks beautiful.
All right. Well, I'm with Ceres now. As I said, I taught middle school science, 6th and 8th grade here in Colorado for the last 15 years. And Ceres is the Cooperative Institute for Research in Environmental Sciences. And I've done 10 years of PD with them as an educator. And they just do a ton of amazing outreach. We have a lot of resources online. Our new website will be launched in the new year. So not only is it heliophysics, but anything else that might be environmentally related, air quality, et cetera, it's worth checking out the website, which I'll give at the end. And the project suite came about from funding from NASA. This is way before my time, and I'm sure Lindsay and Andy can give you more of a history of all this. So Ceres had done some previous work through funding that LASP had gotten from NASA. LASP at the time, who's also at the University of Colorado in Boulder, running the MAVEN mission in terms of that aspect, which I'm sure a lot of you know, didn't have an education outreach arm at the time. So Ceres was supporting that effort. So that's how we're kind of in on this, even though we're not a purely space science organization. So just with this quick session, I've got about 20 minutes, so I'll kind of quickly go through it. A few of you had seen the SDO project suite overview back when I'd initially presented it, and that was before the first NASA review submission. I heard back in end of June, and then things were kind of on a hiatus until we got through our air quality Discover AQ education outreach for the NASA mission this summer. Came back and revisited all the changes. It took a good month and a half, and got this stuff back to John Ensworth at the end of October, and didn't hear back yet, so I thought, may as well just check in and see where things are at, but it's moving forward. And in fact, I might even update one of these module handouts based on all the stuff I learned from Claire. So in terms of the overview, I'm sure most of you probably are familiar with SDO. Did you want to watch the intro video? Give me a thumbs up. Not, it's a great one. And there's so much out here. And like I said, thank goodness for NASA Wavelength, because it's pulling all the amazing stuff back into a single source. So I'm hoping you can watch and listen. This is great for
the sun is different every time we look at it. Those changes in the sun we see here at the Earth as well. We call those effects here at the Earth space weather.
I'm sorry, say it again.
So you are now sharing a different screen than what you originally picked, so you have to go back to share screen and choose where your movie is playing.
Okay.
Slides.
So I do hit stop share?
Nope. You just go up to more. You should have an option. And it'll say share a different screen.
Okay, I see more, and I've got chat, invite, record, disable audio, hide, setting, and leave meeting.
I'm sorry, go down to the bottom to share screen and click that again. My apologies.
Okay, hang on, let me get to where I need to be.
Share screen.
Share new window, is that it?
That's what you
Okay.
need. Yep. And then pick the window that you're
Yay.
Yeah.
Okay, I'm learning so much. I'm like nervous. It's like,
Don't be nervous. It's all good. There we are. Now we see your movie. Perfect.
okay, I will go back to the beginning. So if you haven't seen this stuff, which I'm sure most of you probably have, these are great for the students to kind of get a feel for what's going on with SDO. Let me hit play here. Should be good.
The sun is different every time we look at it. Those changes in the sun we see here at the Earth as well. We call those effects here at the Earth space weather. The Living with a Star program was developed at NASA to bring together all the people who study space weather. The Solar Dynamics Observatory is the first mission of NASA's Living with a Star program. It's designed to study the sun, the root of space weather. SDO has a couple of improvements. The easiest one to think about is we have better cameras. We take a camera that's twice as big as the best one we have in space, and we fly a whole bunch of them on a satellite. Our cameras are 4K by 4K pixels, so that's about 16 million pixels sitting on each camera. We can see images of the full disk of the sun. To see the whole sun in high resolution is better than seeing just a little bit of the sun in high resolution. If we look at a little bit of the sun and we see something happen, every once in a while we'll see that something came in from the side. So you're sitting there watching it and you say, oh, that's cool, that's what I wanted to study. How did that happen? Why did that happen? So you widen out. So now you see what you wanted to see, and you see that wave come in. But the most important thing is that we're going to take pictures very frequently. The best we've done so far with full disk images of the sun is every 3 minutes, and we're going to take them every 10 seconds. That's a lot faster. We'll be able to see things that happen on the sun very quickly that right now we skip. We miss. It's like we look at the tops of the mountains and we miss the valleys in between. SDO will also study the amount of energy the sun puts off in extreme ultraviolet wavelengths. These are very short wavelengths that gets absorbed very high up in our atmosphere, causes the atmosphere to heat, expand, and bring satellites out of orbit. Previous missions have looked at the extreme ultraviolet radiance every 90 minutes. We're going to look at it every 10 seconds. And we're going to see a lot of new stuff, and we're going to learn a lot. The magnetic field is also looked at. We know that this is important because we've never understood the direction of the magnetic field before. And that's part of our research, is to figure out what's happening to the magnetic field of the sun. And by knowing its direction, that gives us another piece of information to understand where it comes from and how it gets converted into solar activity. The instruments on SDO are designed to work together. One measures magnetic field, one measures what the magnetic field does, and one measures what we see that affects us here at the Earth. SDO would like to be able to predict space weather so that we can look at the sun, know something's going to happen, and call people up and let them know.
So I wonder if you put the chat, maybe we can view the movie over our break. If you put
it's all done now.
That window, and then we can each individually. I don't know why it's not. It might have something to do with your bandwidth.
Yeah. Okay. I just lost.
I'm so sorry.
No worry. It's over now. You just pretty much missed it all. But I don't know where I am to escape out of here because I don't have my mouse. There it is. Okay, let me stop this.
The sun is our real, true astrophysical laboratory. If we understand what's going on the sun, we can turn and look outwards to every.
Okay. Oh, crud.
How can I help?
I don't know how to get back to where I was.
So you want to share your window again, so share screen. Yep.
I'm going to just close this window up. Get some here.
Yep.
So I don't see any of you folks. There you. Oh, you're hiding. There you all are. Okay.
Yeah, we're just hiding. Yeah, we see you.
Yeah, so that's the one concern I have with the whole helioviewer thing too, and I'll share about that with when you do things like this with students in the classroom. So I'll share my screen again, get back to here, and sound. Okay, so basically that was a quick gist. Hopefully got most of what was going on, but I think it's a great way to introduce it. And there's the website, which was shared in the chat window, which gives you the full ins and out about the actual mission. Try to move quickly. So the driving questions with regards to SDO is basically that sun-Earth relationship. And so, who cares what's going on with the sun? In fact, I did a presentation with Noah we have, well, they run an 8th grade science day for all Boulder Valley School District 8th grade students if their schools are interested and able to get down to NOAA, which is an amazing opportunity for them. They actually see NOAA in action with what's going on with the various scientists and research. And we did a presentation at the Space Weather Prediction Center, which I just want to share if you haven't known recently, is I have to share another window, right? Share
Yep.
window. And let me just go over here and there.
And also, Jennifer, if you need to switch back and forth between different applications for us to see, you can just choose share your desktop, and then you can flip through that way. We just can see your desktop. So as long as there's work appropriate.
It's a lot of work, nothing exciting. So anyhow, the cool thing, I'm just curious if anyone's seen this. Whoopsie, it was a short acronym for Space Weather Prediction Center. So these are the people that use all the instrumentation that Claire had mentioned to communicate to, like, power, grid, electric companies, et cetera, as to what's going on. So it's kind of like, green is good, you have the yellow and the orange, red kind of warning. So right now our sun's looking pretty mellow, so it kind of gives you these 3 different measurements, the RSG. I'm not going to get into detail of this, but they are using all that instrumentation information from SDO, SOHO, LASCO, etc. And it was really cool being in SWPC and seeing the screens there and the space weather forecasters doing their job. So if you want to tie in the real world science, this was just launched, I think, beginning of November. It had to be put on hold because of that huge sunspot event at the end of October. So they had to wait until nothing happened. And as they say there at SWPC, no news is good news. So if they're doing their job and giving the warnings that we're not losing satellite connections to GPS and power grid supply, things are good. So it's kind of a great website to use. So let me go back to here and share the window. I'm just going to do my desktop, right? So then I can just go back and forth, correct? Okay.
Yep. Yep. We see, if you have it on desktop view, we see whatever you're clicking around on.
Okay. So that's just basically the driving questions behind SDO. How do you bring this into the classroom? Because as Claire said, a lot of this is being used by experts in the field, but it's so accessible and super visual and exciting for kids to kind of understand, what the near star is doing to our planet. So the instrumentation, I'm not going to go into detail since you kind of saw that, but there's 3 of them that are on SDO, and SDO was launched in 2010, has a 5-year mission life cycle, but it has enough fuel to go for 15 years, so hopefully it'll continue just as, SOHO has been still providing information. And I'm not going to share these links, but they're in the activity. And again, that intro video we had for the overall SDO mission also has individual short little 2-minute videos about each of the instruments themselves, which is really great to share and to learn as an educator. So the curriculum overview is very simple in the sense that it's trying to communicate the science, but tying it into like a 5 E's approach of learning with an NGSS aligned curriculum. So it is open and it's not a cookbook type approach to using the science. And so an educator, you can really adapt the opportunity that SDO provides to fit the particular grade level, the particular content that you want to focus on. It's not like a standalone, here's the all you need to know. It really incorporates also existing solar science lessons. So I went to this as an approach, being not a heliophysics expert. My area was 6th grade science, which we didn't have a ton of space science in terms of solar activity and electromagnetic spectrum that got moved to 8th grade here in Colorado. So anyhow, it can be adapted to how you feel and need it best suits your role as an educator with your students. So the curriculum itself is broken down into 4 modules. The one that we'll share with HelioViewer fits into module 2. So these modules have been set up that you can do the whole curriculum over the course of a year, over the course of a quarter. You can do each activity in each module as a standalone activity so that, again, it can fit with your overall scope and sequence of your curriculum that works for your grade level.
Jennifer, can I interrupt you real quick? Is there a link to this that you can provide? I'm assuming that this is online somewhere. Can you tell us where to get that in case people want to see these modules, or is it? I know it's in the slides that you sent earlier.
It will actually, once I get the thumbs up from NASA Review, this will be on NASA Wavelength. And actually, SWPC over at NOAA, the Space Weather Prediction Center, will also have a link to the curriculum. So as soon as I hear back from John Ensworth, I will be posting, it's good to go. And I was hoping I was going to be able to give you that news today. But like I said, it's a big curriculum. I'm just going to escape here and just show you very quickly the general overview. I'm a visual learner, so I'm into the
Jennifer, I'm going to interrupt you just for a second too, and that is that the teachers were emailed your prototype ones are the ones that we are using today.
Yes.
So they won't have all the modules. I think you gave them the first two. Is that right?
That's correct. So can everyone see the screen I just pulled up here? This is basically the modules in a snapshot. So there are 3 modules, and the idea about this, it just kind of kept growing. I thought, being an educator for 15 years, I wanted to get away from the point we're all doing the same thing the same way at the same time, getting to the same information. So the idea is that scientists don't work independently, they work collaboratively. So this really should be completed as a student team, 2 to 4 students. And the idea is that the modules have the same general objective, and again, it follows the 5E approach, so it builds on each other. So the first module is just getting familiar with the sun. There's really not a lot within NGSS that you can focus purely on heliophysics or the sun, but it ties in all the aspects of science education that can be taught through the sun. So these are a lot of resources that were revamped and adapted to SDO that I had gotten from Deborah Scheer over at Stanford Solar Center. She was fantastic to, be wanting to share, and there's other things that are out here that are tied in. So it has kind of a scope and sequence that as the students go through these, they get introductory videos, they can do an activity, they can apply their learning and demonstrate their knowledge. The one we're going to be looking at is 2A, and it focuses on the electromagnetic spectrum. There's also one on magnetism, and then the last activity there for the spectroscopy. Someone mentioned earlier about a magnetometer. I did test this out with my students. I had sponsored the astronomy club, and we actually had that mason jar pop bottle magnetometer put together, and it worked. And it was amazing for the kids to go back to SWPC and then look at the month-long data of solar activity the month of February, this past February, and they could see that their recording of data mirrored this increase in solar activity that was seen on actual scientist data. And the last but not least module is where the students, as they complete one of these 3, so they don't do all 3, they might pick 1A, they might pick 2C, and then 3B. It's up to them how they choose their path. But as they finish each of these modules, they create an artifact, i.e. a HelioViewer movie, that they put together as their team and exhibit. And then the whole class has a presentation as a solar museum. So the idea is that you present your group's exhibit, go and visit other teams' exhibits, so the whole classroom is a museum of solar heliophysics information. And again, that can be as big or as little to what is available with your time frame, interest, etc. So there's support information throughout the curriculum to help you do this. And it's definitely not totally prescribed. You can work it as fits with your situation. So let me get back here and go back to my current slide.
Jennifer, can you show us or tell us what the website is with the solar cycle on there? It was origin.something, origin. I just couldn't find it anywhere when I looked online, just so as I can put it in
these are they're all hyperlinked, and I have like I say, once the curriculum's released, I have a whole appendix of every single URL that's spelled out. So in here, these would just be hyperlinks that will bring you to the website. So I wasn't sure which one you were looking at.
Okay, it was the one in the background actually with this solar cycle on it.
Okay, was it from this page or not? I'm sorry.
You can see it right now. It's right behind your window.
Right behind the window, that one.
Yeah.
That's in the slideshow, yeah. So that's just Space Weather Prediction Center, swpc.noaa.gov. And I will share this slideshow as well with the Wigio that I'm presenting so that you can get to this one. Yeah,
okay, I'm just going to put this link in the chat just so as people can get to it if they want to have a look later on.
Yeah, it's really good. And by the way, I did the actual survey, because if you looked at the old NOAA Space Weather Prediction Center site, it was like, it's not engaging. They don't have the real-time data, near real-time data available. So here you can actually get down and get to their education outreach link, and it's way improved. So much better site. And this, again, just was launched within the last 3+ weeks. So it's really a well-done site now. Sorry, let me get out of here. Since I'm out of the slide, let me just quickly show the NGSS alignment. And again, these are all hyperlinked to NGSS themselves. And I was very conservative on identifying NGSS. I didn't want to overprescribe, so I think, again, you can make the times where it fits with your curriculum, your grade level. Again, this is more middle school, but again, you can adapt it up and down, I believe, to high school, elementary without a problem. So these tell you specifically what are the disciplinary core ideas. So I went with the DCI, but I also then put in the SEPs and the cross-cutting concepts as well to support what you're doing in the classroom. So the SEPs is pretty much the processing of how you do science. They got rid of the scientific investigation element as an individual standard in our state. It's kind of like embedded, but it's nice to know how it's embedded. So that's what the SEPs present with NGSS. And again, these are hyperlinked to the NGSS website. And then the cross-cutting concepts. So where may you tie in? Like, for instance, the EMS is the one that we're going to look at. It ties into patterns, cause and effect, prediction, systems and models, and stability and change. So that can help be taught through studying the sun. Okay, let's get back into here. Almost there. So Claire did a phenomenal job with introducing the Helio viewer deal. This is just background information if you want to get more info about the two causes of space weather, sources of space weather, which are the solar flares and the CMEs, which really impact our planet. And I'm not going to go into detail, but that's all there if needed. And students can do kind of a self, tutorial on this slide if you wanted to cut and paste it into something else that you're doing. And then details about the CMEs, how they're related to the solar flares. And this was, I think, the event that happened in September the 10th, this past September, when we had that potential big space weather event. And here's some images that were produced. They're available through the SDO channel on YouTube and other sources. So here's just an example of AIA and in action between the two different main wavelengths, and 171 and 304 wavelength tend to be the ones that pick up the solar flare activity. And then, as Claire mentioned, the coronagraphs, the C2 and C3. So I'm not going to play those since you kind of already had seen what goes on, but I think it's just an amazing tool for the kids to really have this open-ended opportunity to explore the sun. And again, there's a great tutorial here. I will just click the link here. This is the guide that Claire had referenced, and I think she did a great pulling it, together into, applying it to the actual website versus just, self-teaching, through the guide online. So I would go to her Wigio PowerPoint for sure. This is a great one that I found. Can you guys see this? Can you see that one?
Yep, we can
okay,
see
good.
it.
So Nova Sun Labs has a great little video. It's a quick little intro, and it's more basic to like a J HelioViewer approach. And it's funny, just intuitively, I decided not to do J HelioViewer. This is back in, end of last year, early 2014. I thought between the two, not having it be a standalone internet-based product, I thought J HelioViewer was limited. So I thought the online web-based one was much better, and I'm kind of glad to hear that J HelioViewer is not an option anymore as much, because I think that the one online you can use. So this is a great little resource. The website here is pbs.org, and if you just kind of Google Nova Sun Labs, there's a whole online project that you can do with the kids. I tied in several of these resources. They were so well done, learning about the sun, short little videos, etc. And that kind of explains what Claire had already done, which I think is done. Actually, oops, let me go back up here. So anyhow, during the break, I'm trying to look at the time here. We're just at past noon. The information that you were sent is basically the 2A module for the SDO project suite. And so within that, you'll see the teacher notes are on the right-hand margin. Then you've got the student guide mirrored on the left. So what the students get is on the left, and you kind of have the same information they're working from. So this is a thumbnail of what should be checked into that HelioViewer box on the left that Claire had shared. And this is kind of the step-by-step. If the students do this, you should be able to see an image that has the elements tagged. And I felt it was important to kind of, show them where the flares are at and where the CMEs are with just those little tiny, Google Earth type little flags. So what I would love for you to do is don't feel this is the only way you can do this. Change with whatever wavelength you want to go with. I'm hoping that we can stick within the SDO AIA imagery. I didn't include the LASCO piece, even though with the CMEs, that's obviously the way to go. But you can still see on this that it'll have a flag out in the chronosphere of where the CME is at, and that kind of ties in where do CMEs, get monitored and measured, and where are the flares generating and starting from. So I would love for people during the break to kind of mess around with it, maybe save an image. I kept it pretty short because of the time step. The bigger it is, the longer it takes for your video to download. I had one teacher, I presented this at the last summit, and then she wrote back to Erin Wood over at last saying, oh, we were getting like the 6-hour note that it would take that long to generate a movie. And I just was wondering how and what that happened, if they had every kid doing this on a very, slow bandwidth of computer connection with their school, or were they doing a ton of solar events? I didn't know what the problem was, and I hadn't heard back, so I don't really know. So I would say probably 2 is fine. CMEs and flares. I said in the instructions that maybe pick a couple more interesting things that they just might want to explore, like a filament or a coronal hole, something like that, just to be open-ended. So,
and this is that's the activity. If you'll go back 2 slides, Jennifer, that's the actual activity that we want you to do over the break. And so I don't know if maybe we can leave the instructions up. I know you sent the module, there's the module 2A instructions.
Yeah.
But rather than just pick, and you see in her step 1, she gives you the date to pick. Since we've kind of already seen how that works with Claire, we're going to ask that everybody pick their birthday. Or a special day to them, but a birthday would be great. And those are when you go through this and get your results for your image, then we'll be sharing those after the break is over. So, so that rather than putting in 2014 September 9th, we're going to ask that you put in your birthday, of course, and you can pick of this year. I should say that. I'm sorry. Your
birthday. It could be last year. If your birthday is still to come, then make it 2013.
Yes. Yeah, then make it a year ago. Thank you, Claire. Yes. So your birthday within the last year from this date. So good point. I guess people might have birthdays in December. This is true.
when we enter the date, it's not our birthday, right? It's like a day.
Well, it's
your day.
It's not your day of birth. It's the day you celebrate your birthday.
But I remember that you said don't pick the actual day because we should go somewhere in the middle in the date.
No, what I said was that the time and date that you put in there, so the duration of your movie is only going to be a day or 2. And so, or it could even be a few hours. You can make it however long you want it to be. So the time and date that you put in there should still be on your birthday. And then if you make it a day, let's say you make it a 1-day movie. So if you make the date your birthday and the time noon, and then make it a 1-day movie, it should start at 100 hours on the beginning of your birthday and go through to 11:59 on the end of your birthday. So it should be your whole day. So it will still be your birthday, but then it's the middle of the movie, and don't make your movie longer than a day or 2 just for demonstration here, because it will take a long time to process.
And we're all going to follow Jennifer's directions, which is takes us exactly through what you just said, Claire. So if you follow Jennifer's directions step by step, you'll be just fine.
Yeah, and I'll leave that up. I just have like 1 more minute to show them the actual activity that was sent to them, just to kind of package that up before we finish. You want me to do that after the break? Because I just wanted this not to be taken that, you're just going to be doing helio here. This is actually part of a scope and sequence of understanding the science behind it all.
And so we're going to do this part, and then after the break, and they show that, then you can go through the rest of that. Does that sound okay?
Good.
Awesome. Is this a good place to stop then, Jennifer?
Well, let me just go down one more screen and
absolutely.
Yeah, I mean, I just had the movie, but we looked at how that had happened, and then we're going to get back to the feedback of the discussion element. So yeah, this is just my 1-day deal when we had that big CME solar flare in September. FYI, there was a great solar flare, I think it was August 24th as well. So we had a lot of stuff the last,
Can you play your movie so we can check that?
Yeah, that's exactly what I was just going to say. Thanks, Claire.
Okay, and I made this be a week long, and so it just kind of shows you that, and you can also stop and start this by clicking on it. So if you're seeing something, the students can actually slow down. You see a little CME popping out here. You know, the opacity piece that Claire mentioned might actually add more to it. So you can add and subtract this. So there's some meaning to the imagery that you're seeing. The instrumentation AI has been having a little bit of problem. That's why you're seeing some of these gaps, I believe. And again, this is just from September. But you can talk about, you know, where are these sunspots locating, where the flares at. You got the equator of the sun, a high solar max element happening here. It's really a great tool. So
especially if you add in your coronagraphs here then, and you zoom out it even
yes,
a little bit, then you'd see all those CMEs popping out as the flags appear.
right. So I just tried to save it shortly, but you could definitely put a LASCO piece in here and get that coronagraph in there for sure. So, all right.
Cool.
I can't wait to see what everybody's birthdays look like. And to do that. All right. Well, it is in my time. It is 10 after the hour. So it's 10 after whatever hour you're at in your part of the world. And so we said that we were going to come back. We're going to give you a 30-minute break, which means